today we are going to be doing 2.1b. So we did 2.1a and then we did some 2.2 and now we're coming back to 2.1. So today is all talking about when a function is differentiable. All right, so a function is not differentiable if any of the following happen. All right, so here's the first thing. All right, if the function is not continuous, then you can't take the derivative at that point. So what I mean by that is if there's a hole in the graph, then we can't draw a tangent line at that point because there's nothing that actually exists there. So if there's a hole, you can't take a derivative of it at that point right there, whatever that c value, that x value is. Or if there's an asymptote, we can't draw a tangent line between these two graphs because the asymptote is here. So again, holes and asymptotes can't take a derivative. All right, the second one is if the limit does not exist. Okay, well, the limit does not exist would be anything that looks like this graph right here. At this value right here, the limit is not existing because it's going up here and down here and they're not meeting up anywhere. So whatever this value is, the limit doesn't exist there, so therefore you cannot take the derivative at that point. All right, anywhere there is a sharp turn. So again, a derivative is the slope of the tangent line. Well, you can't draw a tangent line at a sharp turn. So what I mean by that is something that looks like this. F of x equals the absolute value of x minus 3. Well, if I were to graph that, it would look something like this. And right there, there's your sharp turn. So at 3, we can't take the derivative because there's a sharp turn there. All right, the last one is a vertical tangent. Or can I write it? Tangent. But for us right now, we are only going to concentrate on the first 3. The fourth happens so rarely that they'll touch on it in calculus. We're not going to deal with it in this pre-calc class. So you need to know if there's a hole or an asymptote, if it does not exist, or if there's a sharp turn. Those are the 3 main spots where you cannot take a derivative. Okay, we are going to look at 3 examples here for you to decide where it is differentiable or not. All right, find any x values where the function is not differentiable. All right, so here's our first one. Well, when I look at this, a very quick graph would put that V-shaped graph shifted over at 4. So my graph is differentiable everywhere except at 4 because that's where there's a sharp turn. So not differentiable at x equals 4 because of a sharp turn. All right, there's number 1. Short and sweet. Okay, number 2 has a little bit more going on. All right, so we got this piecewise function here. So I think the easiest thing to do is to graph this piecewise. All right, so I'm going to put it over here. All right, so if x is greater than or equal to 0, I get 0, 4, and 1, 3. So 0, 4, I have a closed. 1, 3, I have closed. And it's going to look like that half of the parabola. The x being greater than or less than 0. I have 0, 1. And if I put in a -1, I get 2. All right, so 0, 1, but now I have an open circle. -1, 2, I have closed. Again, it's curved. All right, so where is it not differentiable? Well, I'm saying it's not differentiable at x equals 0 because there's this gap in the graph, okay, and there's that hole right here, okay? So not differentiable. Because there's that hole or gap in the graph. All right, last one. Let's look at this first. What is the limit at 0? Well, the limit at 0, if I'm on the right-hand side, so the limit from the right-hand side, if I'm on this side walking, I get a limit of 4. If I'm on the left-hand side and I'm walking, I have a limit at 1. So that means my overall limit at 0 does not exist. So not only is there a hole or a gap, but probably a more definite answer would be it's because the limit does not exist there. All right, last one. All right, so when I look at this, it looks like I have a parabola and a line. So that should make it a little bit easier to graph for us. All right, so bigger than 0, so at 0, 0, 1, 1, 2, 4. So I'm going to have this parabola on that side. Over here, I have a negative sloped line. So if I am at 0, I'm at 0, but it's an open circle. At -1, I'm at +1. So paying attention to what kind of graph you have is a big deal in this instance, because this is a curve. This is a line. When a line and a parabola come and meet here, that is a sharp turn. So my graph here, or this function, is not differentiable at x equals 0, and the reason is that there's a sharp turn. And that's always going to be the case if you have a line and a parabola meeting up. There's going to be a sharp turn there. So you don't necessarily have to graph it as long as you can tell the meetup place. So I always graph it to make it a little bit easier on myself. Okay, so holes and asymptotes, that creates that gap there in that piecewise. You could have does not exist limits, or you could have sharp turns. Those are the 3 big ways that you cannot take a derivative. All right, let us know if you have questions. All right, have a good day. Bye-bye.